Okay, so let's discuss about histogram of oriented gradients. So just to give you an intuition, there is an image, and you can see this is a grayscale image, only this part. Okay, so you can see, so all these are intensity values. For example, 0 means completely dark, and 100 means somewhat grayish white, and 25 means gray, 50 means gray. Okay, so these are different intensity values, and what histogram of oriented gradients does is it considers gradient magnitude and direction to obtain the feature vector. We all know what feature is, what features are. Okay, so in this HOG, we extract features in the form of a vector, and vector we all know, a single linear matrix, right? So for example, you can see the intensity change over here. For example, the intensity value is 100, right? The intensity value is 50 and intensity value is 100. So where do you think in this complete image, where do you think that there is the most intensity change, the rapid most intensity change? You can see it is from 0 to 100, right? This is a kind of dark, and this is kind of white. So you can see there is a complete 100 unit change of intensity values. And while if you consider this, so even if you consider 0 to 50 or you consider 50 to 100, the change in intensity value is 50. Okay, so on the first priority, we can say that this is 0 to 100. This is a very rapid change, and then this is a change of 50 units, right? And if we talk about this triangle over here, you can see the intensity of this region is 50, and the intensity of this region is 25. So that's a 25 unit change of gradient. Okay, so you can see of intensity. So what HOG considers is, it calculates the intensity differences. For example, 0 to 100, so there will be 100 unit of intensity change. So the gradient magnitude will be 100. Okay, so it considers the modulus. For example, the positive value. So if you are doing 100, 0 minus 100, so even if you are getting minus 100, we are only going to consider the magnitude, the plus value. So that will be counted as plus 100. Okay, now it also considers the change, the direction, the change of direction. For example, 0 to 100, so the direction is downward, and here 0 to 100, the direction is right. Okay, and here the direction of 100 to 0 is downward. So it considers magnitude and direction both. Okay, so this was the intuition. Now let us discuss in much detail. So if you see the syllabus, there are many things of HOG. So I would draw your attention here, because in this single video you will get a lot of knowledge about every single topic that is mentioned in your syllabus, in your syllabus scheme, what you say. Okay, so there are multiple topics, and everything will be covered in this video only. Okay, so pay attention here. And if at any point if you find difficult to understand, you can always start from zero. I mean the video. You can always start over the video, or in case if it is again not clear to you, you can just ask your CR or text me. We'll arrange a Google Meet. Now this is an image. A complete image. So what it does is it extracts a region. For example, this rectangle or this rectangle. So it draws a rectangle around this human. Okay, so now since now this is the, so what it does is it crops a portion of 1:2 ratio. So you can see 150 by 300. 150 by 300. So it crops a small patch of image of 1:2 ratio. Now what it does is, next step is to resize the image in 64 by 128 form. Okay, so in any algorithm you are considering HOG will only resize the image in this form, in these dimensions only. Okay, so now first step is to extract a patch of image of 1:2 ratio, 1:2 ratio, and then resize it to 64 cross 128 form. Okay, clear? Now once this image, this partial image is clear to you, now it will divide it into further grids. Okay, now you can see these are 8 cross 16 grids. Now these are different grids, and now pay attention, in each grid there will be 8 by 8 pixels. Okay, each grid is of 8 cross 8 pixels. Clear? Let me repeat. This is a complete image. We extracted a patch of this image of 1:2 ratio. Now this is that image, 1:2 ratio. Now again we resize this image into 64 by 128 form. Now it is up to you. You can also directly extract a patch of 64 cross 128 instead of following these two steps. Now once this patch is available, you can divide this patch into grids. Okay, so you can see 8 by 16. These are our different grids, and now in each grid there are 8 by 8 pixels. Okay, understood? Now next thing is so let's suppose there are these all the intensity values filled in this array 8 by 8 image. So I'm only considering these 9 values for ease of understanding. Okay, so there are these values. Now what it does is it considers only x direction and y direction. Are you getting what I'm saying? It only considers x direction and y direction. So if I'm considering this pixel, the pixel 60, so it will, so if you can remember, we discussed about the four connectedness, right? 40, 70 and 20 and 70. So only these values will be considered. Okay, clear to you? Now moving ahead, so what we did is divided this image into grid forms. Now in each grid we are considering all these cells. We call it cells. See, these are blocks. 1, 2, 3, 4. These all are called blocks, and these are called cells. Okay, clear? Now in the cells I'm only considering these 9 values. Okay, so there should be 8 by 8 values in this image, but I'm only considering these 5 values. And now so we always consider the mid one. So considering 60, we'll only consider the 4 connected neighbors. For example, these 2 and these 2. Okay, clear? Now moving ahead, since I ignored these are the remaining 4 values we have. So what we are doing now is, in the x direction we are finding the difference. In the x direction we are finding the difference. So for example, 40 minus 70 will be 30, minus 30, and we are considering the positive value. Okay, so we are considering the positive value over here. So 40 minus 70 is 30. Now same goes for y direction. 20 minus 70 is minus 50, but since we are considering only positive values, that will be your 50. Now this should be clear to you. Okay, very simple and basic thing. Now next thing is, these are the main requirements of HOG. These are the main requirements. What I said earlier is HOG works on magnitude and direction. Okay, so magnitude, how we find magnitude is this formula. We apply this formula. For example, for x we have 30 square, and for y we have 50 square. Now we added the sum of these squares, and then we found the square root of the values. So that will be approximately 58. And okay, so is this clear to you? This is a simple formula. square root of x square plus y square, as simple as that. Okay, so by this we can find the gradient magnitude. Okay, we'll discuss this again. Okay, but again, if this thing should be clear to you at this point only, that will be better for you. Okay, so this is your magnitude. Now what did I say is we also consider the direction with magnitude. So here we are also calculating the direction. So the formula says tan inverse x by y, as simple as that. Tan inverse x is 30, y is 50, and when you simplify these values, you will find the values around 30 degree. Okay, so the gradient direction will be your 30 degree. I hope this is clear to you. We are simply finding the difference in in the gradients. Okay, now once that the difference is clear, we are simply applying these formula. So by applying this formula, we found the gradient magnitude and gradient direction. So this was only for this value. Now suppose there are 8 by 8 values. So every value, so there will be more values. Okay, not just one value. This is for ease of understanding. Moving ahead. Okay, now suppose we have found more such values. Okay, these are different magnitudes and these are different gradient directions. Okay, now listen to me very carefully. What we are doing is we are creating bins. Okay, so see, whatever the angle will be, it won't be more than 180 degrees, right? It won't be more than 180 degrees. So what we are doing is we are dividing 180, we are dividing we are dividing 180 in the 20 bins. Sorry, in the range of 20, so it will give you 9. Okay, or what you say, we are dividing into 9 bins. So on an average the range should be 20. Okay, so we are dividing 180 in 9 parts. Okay, so this will say that 0 to 20, 20 to 40, 40 to 60, 60 to 80, likewise, and the last one will be 160 to 180. Okay, clear? 0 to 20, 20 to 40, 20 to 40, 40 to 60, and then 160 to 180. Okay, now if it's still not clear to you, it will be clear. It will be clear as I'll explain this. Okay, so this is your gradient magnitude and this is your gradient direction. Now let's insert a text box. Okay, here. Now let's suppose now first of all, this is your now first of all we found the gradient magnitude is 60 and the gradient direction is 20. So out of all the directions, in the 20th direction we found the gradient magnitude is 60. So first of all we'll ignore this 0, and in the 20 okay, so in the 20 we'll simply write 60. Okay, clear? We from left to right scanning, we found first there is a 20 direction. The direction is 20 degrees. So in the 20 degrees bin means any box, any folder, what you say. So in this bin we are inserting value 60. Okay, clear? Now next is 40. Now the corresponding value to this 40 is 60. So what we are going to do next, in the 40s box, in the 40s bin, we are inserting 60. Okay, clear? Now next is, as we move ahead, we found 30 over here. Now listen to this carefully. Now we want 30. The direction is 30 and the magnitude is 60. Okay, so can you see 30 here? The 30 is nowhere written. Okay, but we know that 30 lies between 20 and 40, right? Between 20 and 40. 30 will be somewhere here, right? So here what we're gonna do is, we're gonna see, if we talk about 30, it is 10 away from 20, and this is 10 values before 40, right? It is in exactly mid of 20 to 40. So what we'll do is, we'll divide this 60 into two equal parts, 30 and 30. Clear? Why we divided this by 2? Because the 30 is very in very mid from 20 to 40. That's why it was divided very equally. Now next is 25. The corresponding value to 25 is 60. Now again, the 25 is a little bit far away from 20 and much far from 40. Okay, are you getting it? So if we see mathematically, we should divide it by 3 by 4 and 1 by 4. Okay, since this is very close to 25, so we are considering ratios. If you can see it, we are considering ratios. So we are dividing it with 3 by 4 and 1 by 4. So the value here should be 45 and the value here should be 15. Okay, I hope this is clear to you. So from left to right scanning, first we saw that there is a 20-degree angle, and 20-degree angle, the corresponding value is 60. So we directly write 60 over here. Now next is 40. 40 is provided here, so we directly wrote corresponding value here. Now next is 30. Now 30 is equally far from 20 and 40. So we equally divided this 60 into two parts. Now 30 is written here, 30 is written here. Okay, now next is 25, and we know that 25 is more near to 20 and a bit far from 40. So what we did is, we took ratios. So if we consider ratios, the 3 by 4th part should be here and 1/4 should be here. So that's why we divided this into two parts, and the 3 by 4th part comes here and the 1/4 part comes here. Okay, now what we are going to do is, we'll simply add these values. Okay, so if we are going to add these, what are we getting? 90 and 45, which is your 135. Okay, this is just a sum. Okay, now moving ahead, if we are summing this, 90, 100 and 105, so we are getting 105 over here. Okay, so likewise, see, this is just a part, this is a very small part of image. Okay, if we are going to consider the whole image, there will be multiple values. Okay, the sum will be more and there will be more bins. Okay, so here we considered these cells and these are the values. So now we are obtaining our feature vector. Now our feature vector will consist the values corresponding to these. Now let's suppose this is your feature vector. So 0, 135, 105 and likewise. So there will be some value, there will be some value, there will be some value. Okay, so this is your feature vector. Is this clear? So this is your feature vector. Okay, so now Feature vector can be used in many forms, but let us discuss further about normalization and all. Now, okay, you can also see this image. What it does is, for example, this is for 20 degree. Sorry, this is for 0 degree. This is for 20 degree. This is for 40 degree. This is for 60 degree. So the vectors can also be represented in this form. And now, by looking at this, you can say the highest magnitude is of 60 degree. Okay, now the second highest is of 20 degree. Okay, you can also see the 20 degrees highest among these three. Okay, so you can say we have not considered all the values. अगर हमने सारी वैल्यूज कंसिडर करी होती, then 60 की वैल्यू जो करस्पॉन्डिंग वैल्यू होती वो और हायर होती. Okay, so that's why we can also represent feature vector with this form. Okay, now next is, since we are considering this, this is only one cell. Okay, we are considering only one cell. So there are many cells that combine to create one block. Okay, this is hope this is clear to you. All these calculations are for different cells, and these cells are part of grid. These blocks, for example, this is one block, so there will be all different cells. So there will be one feature vector. Okay, see, this feature vector is for one grid, for one block. Okay, so there will be multiple feature vectors. There will be multiple feature vector. For example, this is 1 by 9 matrix. So there will be multiple 1 by 9 vectors for each block. Okay. So this was only one cell that we have discussed. So likewise, there will be 1 by 9 vectors for all the blocks. For example, 1, 2, this is up to 9, then this is up to 9. So likewise, there will be many numbers of these lines. So now since we have seen different values. For example, some of the values are very small and some of the values are very large. For example, we have seen 0, we have seen 135, we have seen 105, there will be 20, there will be 40. So the range is very large. So what we are doing here is we are normalizing this range from 0 to 1. This is called block normalization. So for each block we are normalizing these values from the range 0 to 1. Okay, so all these different values will be mapped from 0 to 1. Okay, so now what is the procedure of normalization? There are only two steps. First step is to find the minimum. Okay, out of all the cells in the block, you are finding the minimum and subtracting the same from each value of the block. For example, this is your, for example, if let's suppose 10 is your minimum, so you are subtracting 10 from 135, from 105 and all these values. Okay, so this is your first step, and the second step says find the maximum value and divide it with each value. So for example, maximum value over here is 135. Maximum value is 135. So maximum value will be divided from 105, will be divided from 0, and likewise. Okay, so by this, when you will follow these two steps for each block, the output will be block in a normalized form. Okay, so I hope this would be clear to you. Now let's recap. So what I said, HOG works on direction and magnitude. For example, these are different intensity values, 0 to 100, 50 to 100. So but it cares more, it also cares about the direction of change. For example, 0 to 100, the direction is downward, the direction is right and down and up. Okay, all these. And now we are taking an image, we are taking a patch of 1:2 ratio, 1:2 ratio, and we are resizing it to fit 64 cross 180 to 128 form. And now if this form is clear to you, it will be divided into further grids. Now these grids are called blocks. Okay, these are blocks, and inside each block there will be 8 by 8 pixels. Okay, and these are called cells. Now we'll simply find the 4 connectedness and we'll find the difference, and we'll take the positive value. Okay, now since x and y direction is clear to you, we'll apply these two formulas to obtain gradient magnitude and gradient direction. Now since these two are clear to you, there will be more values, right? So if we map all these values, some of the values will look like this. Now what we'll do is we'll simply go to gradient direction, and we'll divide this by 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So there will be total 9 bins, 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 where we store these values. So for example, in 20 degree, we'll write 60 directly because 20 is written over here directly. So 60 is written, and in the 40, 60 is written, so directly we wrote 60. And now for 30, we know that 30 is between 20 and 40. So we'll divide 30 into 60 into 2 parts, 30 and 30. Next is 25. 25 is more near to 20, so we'll give a major part to 20 and a minor part to 40. And this can also be represented in this form: 0, 20, 40, 60, 80, likewise. Now whatever we have discussed was only one cell. So So there will be multiple cells to form a block. Likewise, this is your feature vector, and if we consider all the blocks, this will be your vector, one vector. Okay, concatenated vector of each grid. For example, this grid, you can see this vector. Okay, and for second grid, you can see second vector. So this will be your very huge vector. Now next thing is this was only for one. So now what if now next step is to normalize these values. For example, we can see 0, 135, 105. So we are normalizing this to fit a range of 0 to 1. So the process is very simple. First of all, we'll find the minimum. For example, minimum here is let's suppose 10. So we'll subtract 10 from each value, and next step is find maximum and divide it with each value. For example, maximum is 135. So we'll divide each and every value with 135. So this is how block normalization is done. Okay, now feature vector looks something like this. So this is the visualization of feature vectors. How you visualize the feature vectors. Okay, so in this arrow you can see this is the feature vector of this arrow. And if you can remember, we already have discussed something like this, right? So what we are doing is we are extracting, this is an image, we are extracting the HOG features which will look something like this, and now there will be a template. We all know what template matching is. Okay, so we are extracting this HOG features out of this image, and now we are convolving these HOG features with a predefined human model, and if it matches, we are giving it to a classifier. You can say support vector machine. So now the classifier will say whether it is a human or not. So this is how HOG works. And now there is a slide that I inserted for pre-processing. This is a very simple slide, you can read it. Now next thing is image gradient calculation. Now we already have discussed something like this, but you can also consider this. So for example, image gradient calculation. Now this is your image, consider this any value. Okay, so gradient says now this is your formula. See, gradient is very simple thing that you know. Gradient मैंने आपको पहले ही बताया था कि change in intensity values, gradual change. Okay, and that's how we can also detect edges that we also have discussed कि हम first derivative लेते हैं, second derivative लेते हैं. Likewise, you can detect the edge, right? And here, so this is the formula that and if I remember, we already have discussed it, but again let's discuss in brief detail. So measure of change in image function f in x and y direction. So delta f and delta x and delta y says that this is the change in x direction and this is your change in y direction, and this is your del f that we already have discussed. Okay, so this is the change in x direction and this is change in y direction. Now there are two type of gradients we can see. So this gradient is in x direction. The change is in x direction. If you consider the y direction, for example, this line, horizontal line, there is no change. In this horizontal line there is no change. But if we consider this line, this horizontal line, sorry, there is no change in vertical lines, but there is a change in horizontal line. Okay, so in along the x-axis there is a change. So what we are going to do is we're going to ignore the y coordinate over here. Okay, so likewise, if we are seeing the change in y direction, so x portion will be 0. So this is how we calculate the gradient. And you can also see if the direction is if it is considering the both x and y directions, so we have to consider them both. Now you can also see gradient points in the direction of most rapid increase in intensity. Okay, we know this, and this we have already discussed, just like in the very easier form, just like this we have discussed this. This is the same thing. Okay, so gradient direction is tan inverse y and x. Okay, and gradient magnitude provides edge strength. Okay, so you can see we have discussed about this, and we also have discussed about this. This is the same thing. Okay, so that's why I was saying that you need to just watch this video maybe 2 to 3 times, and most of the things will be clear to you.